Hello, welcome to ANS Solver. This is the fifth question of the paper. So the curve has an equation e raised to minus 2x, okay, into ln x minus 1. So I'll write it down first, okay. Now this has a stationary point where x equals to p. So I need to show that p satisfies this equation where x, x of x denotes e of x, e raised to x. So what we need to do is, because I have a stationary point, this indicates that I have dy by dx which is equal to 0. So first I'll calculate my dy by dx, for which I'll use something called as a product rule, because a variable is multiplied by another variable. So now I have v, which is ln x minus 1, with u dash, okay, which is e raised to minus 2x as it is, multiplied by the differentiation of minus 2x, which is minus 2. And now v dash is simply 1 over x minus 1. So I can write u dash finally as minus 2 e raised to minus 2x. Now the formula which I use is simply uv dash plus vu dash, correct? So uv dash is simply e raised to minus 2x over x minus 1, plus vu dash is simply minus 2 e raised to minus 2x ln x minus 1. But now I told you, because it's a stationary point, my dy by dx is equal to 0. So I equate it to 0. So I get e raised to minus 2x over x minus 1 equals to 2 e raised to minus 2x ln x minus 1. I can simply cut this here, correct? So, and I can write this as 1 over 2 into x minus 1 equals to ln x minus 1, which can be written as ln x minus 1 equals to 1 over 2 into x minus 1. Now, an important log property which I can use is simply log of b with the base a is equal to c, which can be written as b equals to a raised to c. So I can simply write this basically as x minus 1 equals to e raised to 1 over 2 into x minus 1, which I can write as x equals to now 1 plus e raised to x can be denoted as x with x. So I can write this as x with 1 over 2 into x minus 1, which is what I needed to show. Now the part 2, verify by calculation that p lies between 2.2 and 2.6. So first I can write this equation as x minus 1 minus e raised to 1 over 2 into x minus 1. Agreed? Equal to 0, but you don't need to write it for now. Now what you can do is, you can write 2.2 here, you can write 2.6 here. And what you do is, in the place of x, first put 2.2 minus 1 minus e raised to 1 over 2 into 2.2 minus 1. This 2.2 comes here, okay? So simply now solve this on your calci. Even I'm doing it, give me 1 second. So this is the numerical solution chapter. So here they simply just, the stuff here is repeated a lot. Okay? Like it's the same process over and over again. So when I solve this on the calci, I get negative 0.31639. I care more about the sign, which is negative. Now here, in the place of 2.2, now just put 2.6. Just remove 2.2 and write 2.6 there, exactly there. Okay, on the calci. So when I do that, I get my answer as positive 0.23316. Now, p lies in between these values only if there's a change of sign. And as you can see, there's a change of sign. So you can simply say change of sign, change in sign, hence verified. Okay. Now, use an iterative formula based on the equation in part 1 to determine the two decimal places. Give each iteration to 4 decimal places. So I can simply now write this as, I'll just take a little bit of time, xn plus 1 equals to 1 plus e raised to 1 over 2x minus 1. 1 over 2 into x raised to n minus 1. Now, the first thing I do is I take my n as 0. When I take my n as 0, I get x1 equals to 1 plus e raised to 1 over 2 into x0 minus 1. Now, my x0 can basically be 2.2 or 2.6. Okay, because I know p lies between them. So for now, let me take this as 2.2. So I can write this as x1 equals to 1 plus e raised to 1 over 2 into 2.2 minus 1. Okay, so now I can simply use my calc and substitute this into the equation. Okay, so write exactly this on your calc, because now we'll have to use our calc a lot, because iteration is fully about the calc. Now I get this as 2.5169. Now for x2, what I simply do is, in the place of 2.2, remove 2.2 and click on the answer button. Okay, when you click on the answer button, I simply get my value as 2.3904. So my x3, for x3 I simply click on equal to again to get 2.4327. x4 also, okay, I keep on basically clicking on equal to get 2.42146. x5 also has 2.42146. x6 also has 2.42146. Now if you see from the last 3 iterations, okay, my value is recurring. Okay, that basically means how many ever times I click on equal to, this is my final answer. So my final answer is basically 2.42, which I needed to write to 2 decimal places. Okay.